load balancer. Yeah. So we spoke about EC2s, we spoke it about load balancers, we spoke it about lambdas. These are all meant for compute. So which means like basically you do some logical operations, computing operations, be it front end, be it middle tier or back end. Okay, that's the compute layer. And next, we also spoke about our storage layer, which is majorly S3. So as I've mentioned earlier, S3 is simple storage service coming from AWS, and it's we can upload huge amounts of data, and even one object of 5 TB size can be uploaded, and it's an unlimited storage. And we in cloud, I've given examples as well, like everything interacts with S3 and stores all of the media files, image, audio, all types of MIME types are stored in S3. And we also spoke about CloudFront, which is a CDN, content delivery network. Okay. So it's for ensuring that we have low latencies when we make requests coming all throughout the world. So we wanted to make sure the request is served within a very small time period so that the user experience is really good. So that's our storage where our CloudFront would interact with S3, and CloudFront can also interact with the backend server. So that's also there, but we have seen a demo on S3. And the last session, we discussed about IAM policies and CloudWatch and CloudTrail. So IAM policies are the core, like IAM roles and policies are the core because they get attached to every AWS resource which we create, be it S3, be it an EC2 instance, be it a Lambda, be it a database. So all of the instances, or I would call it as resources, are tied to an IAM role. So this IAM role is basically for identity and access management. We have seen how we can create a policy, how we can select a service, how we can add actions, allow actions. So we have given some demo on, let's say, Lambda accessing S3. Initially, it was not having S3 access. So it threw error like access denied, fetching objects from that particular bucket, S3 bucket. Then we added Amazon S3 permissions, after which it was able to fetch the contents from S3. So similarly, we also discussed like we need to have least privilege actions, which means like we do not want to over give permissions. So it should not be like too permissive. So you need to restrict it to what permissions they require. So that's a good practice so that we don't misuse our environment, or someone else would not misuse our environment. So being a cloud engineer, that's one of our shared responsibility model, which I've mentioned it earlier as well. Any cloud provider, when it comes to security, it's a shared responsibility model coming from both the service provider and both from the consumers as well. In this case, us, who is actually creating resources for our organizations or for individuals. So they would take care of certain level of security, and we should take care of certain level of security. So IAM plays a major role along with security groups, along with firewalls. So we should pay attention to IAM roles and policies. So we have discussed about IAM users, individual IAM users, IAM groups, and finally IAM roles. IAM roles for larger organizations, and we can also federate those IAM roles, is what I told. Like you can connect, you need not again create individual users in our AWS account. Rather, you can federate it to Facebook, Active Directory, or some other identity provider in backend, so that you don't want to maintain those users in our database or in this AWS console. So that's one thing which we had discussed. And what else? Yeah, we discussed about CloudWatch, which is again an integral portion of AWS. So CloudWatch, it's a logging tool, monitoring tool. So where we can see all the logs aggregated into it. So let's say if I'm running an EC2 instance where there is an application which is being deployed onto it. So we need to understand here a couple of things. I know I'm shifting gears, but yeah. So as I mentioned about security, it's a shared responsibility model between AWS and us. Being a cloud engineer, you call it as a cloud engineer, cloud developer, cloud administrator. So we also have certain roles and responsibilities, and let's say, we are
Sampath, you got stuck. Sampath, are you there? Ladies, are you able to see Sampath? No. Yeah, maybe he lost network or. Hmm. Sampath, you got freeze. We lost him. Please wait for 2 minutes, ladies.
kicked out of the meeting.
Yes, yes, Sampath.
Okay,
We
thanks.
lost. Yeah.
So coming again back to the shared responsibility model. So I was talking about how cloud engineers are responsible for setting up the environments where they would get data of the ports, like what port they need to accept, let's say, incoming ports. So some applications would be using 8888, and some applications would be deployed on port 443. So that information you would get it from the developer, and being a cloud engineer, you would be responsible for opening that port on the security groups. And these security groups, I've shown you earlier, where we have attached it to EC2 instances, where we have attached it to Lambdas. So that security groups are the key ones, where you would write a rule saying like, okay, I need to accept 443 because my application is deployed on 443, and from where. So basically, let's say I need to give us IP range, or at least an particular IP. Let's say it has to be accessed only from my particular laptop. Then in that case, I would open IP config. I would get my IP, and I would create a security group rule saying like, accept 443 requests coming only from this particular IP. So that's how we create a security group rule, and attach it to our application. So that's how we are responsible for maintaining or creating the infrastructure for the developers. So once we create the infrastructure, the developers are going to deploy their application. So that's the uh, thin line which we need to see here, where cloud engineers and administrators are responsible for provisioning the infra based on the requirements, and deployment is taken care by the developers. And on the deployment, they can actually log in manually and deploy the application, or there are multiple ways of automations. So we spoke about bootstrapping of servers, where we use AMIs to get the application by itself bootstrapped into it. Or we discussed about Chef and Ansible. Those are again automation tools, where they are used to download the package and install the application through an automation instead of manual way. Okay, so there are multiple ways, and every so developers are responsible for creating their application and creating that package. Let's say Docker image also they can create. Docker image, we spoke about it. It once the Docker image is created, it will have all the packages and you can install it on one machine, and you can similarly when you install it on another machine, the same application comes up. So there is no discrepancy. Even if you miss some installation steps, but with the advantage of Docker images, there is no need for installation steps because already it is installed on particular machine with that Docker image, and the same image would, when you install it on another machine, it would work. So every team has its own responsibilities. Some will have some teams would say like, no, I would need Docker images. So they have their Docker experts. Okay. Or some teams would say like, we have our Java guys, they would deploy something on Java. Again, Python developers are there, so they would deploy in Python. But for all of them, the common guy is a cloud engineer who is responsible for understanding what they wanted to deploy. If they want to deploy containers, which is Docker images, then they would choose, then you are responsible for choosing the right service in cloud. So right service in cloud for deploying containers is two. One is Elastic Container Service, and the other one is Kubernetes Service. So again, you can also deploy it on that same Docker image on EC2 instance as well. So you are responsible, or you are the major factor where you are responsible for handling over the infrastructure to them. So that is what I wanted to stress out, that there's a responsibility which you do and what the actual developers take. And so we spoke about, uh, yeah, I think we digressed from CloudWatch logs, right? So these logs are integral part where every application, when they write some logs to it, because logs are really important in debugging what's going on, whether it's a success message or whether it's a failure, you would be seeing, right? Many developers would use the try catch blocks, and in the catch blocks, they write exceptions, and which would give us more details on what kind of an exception it is to understand what went wrong. So that's key, right? So you wanted to store somewhere those logs. You cannot log into that server and always go through that logs. That is an old way of doing things where we log into the server. But now with cloud, you have this service called as CloudWatch, where these logs are copied it onto CloudWatch. And we have seen this as an example in our Lambda session, where when we were trying to fetch the objects from S3 bucket, we wanted to iterate all over the buckets and list the names of it. And we used, I think, print statement in our Python code. And we have seen in the logs, all the buckets were printed with their names. So that's how logs would help. Even I've shown one more Lambda, which we personally used in our organization, where it says like, in one Lambda, it is making a connection to Redis. It's another database, and it is inserting some data. And I also showed you how this particular print statement is present in our application. So I went into the Git, and I've shown you like, okay, the matching statement, what we have seen it in the log group and what is present in the Git. So how the developer is writing that particular log statement and how it is being progressed or inserted into CloudWatch log group. So we have explained the importance of CloudWatch, which is really integral part. So it's a key thing for many developers, because they would ask, let's say something fails. Okay, some application is not able to perform well. It's getting frequent errors. Okay, so you need to provide some way to developers to log in and view the logs, right? So they cannot be provided with uh, instance login, which means like they cannot be authorized to get into that EC2 instance. Rather, if we provide access to that CloudWatch logs alone, then they can go into that CloudWatch logs, they can analyze what's going wrong. So that's one advantage of CloudWatch. And also CloudWatch is also having multiple features. Over the period of time, they have added one on one. So one feature is CloudWatch events. So events means there are multiple things where you can say like trigger a particular service on a particular day. You can write a cron job, or as in simple terms, it's a scheduler saying like you can create a CloudWatch event. Recently, we call it as Event Bridge, but previously it's called as CloudWatch event. And that CloudWatch event, we can say like every Monday, I need to generate a report. So I need to generate a cost report. So I would create some Lambda function, and Lambda function can be triggered with Alexa. Lambda function can be triggered with CloudWatch. Lambda function can be triggered with S3. Lambda function can be triggered with lot many resources. I think I've shown you that. So in this case, let's say CloudWatch is the triggering criteria or event source for triggering Lambda. So in CloudWatch, we can create a rule like every Monday, trigger this Lambda. That's it. And what happens? I can show you that in our session. I can show you. So every Monday, this Lambda gets triggered and it generates a costing report. So that is one CloudWatch feature. And other feature of CloudWatch is monitoring and metrics. So basically, logs are there for debugging and monitoring, but we need metrics. So metrics means what kind of metrics? You can see CPU metrics of an EC2 instance. You can see CPU memory details, which means I'll also show you that on the console, how the CPU metrics would be, how the memory metrics would be. We can also see like the storage metrics, how much storage is available, and we can see the active user count, like how many people are actually reaching out to my application. So I can see like, is it 400 people at this point of time or 10 people? So this gives a lot of data for our decision making. So let's say, as I mentioned, in the application which I work, so it actually is deployed onto two regions to have high availability, and we wanted to serve content uh, throughout the world. So we thought of deploying it onto east side of America and west side of America, so that because we felt the user base is out there, but still we are not satisfied because the number of requests coming from the west is bit low. So, so how did we get to know like the requests coming from West are low? It is because of this metrics, CloudWatch metrics. So in the load balancer section, I will again show you on the console today, where in the monitoring, where we see the metrics, it talks about what is the request coming into this particular load balancer, which is in East region, and what is the request coming into this particular load balancer, which is in West region. So I can clearly go back to my management saying like, hey, do we really want to spend money on this region? Because this region is hardly getting, do we really want to spend money? Sometimes, even though no, they knew that, okay, the other region, just to check, can you hear me? Can you put it in the chat, please? Can one of you respond if you can hear me? Yeah, thank you. Okay. So it's the business. It's basically the business who has to decide whether I need two regions or one single region, even though, but our responsibility is to provide them with data. Okay. So we need to provide data saying like, these are the number of requests coming in, these are the number of requests coming into the other region. Now you tell me whether I should shut down or not. So they would make some calculative decision on whether to shut it down. But in my case, in my scenario, even though the requests were coming low, management said like, no, we have a contract, we have a policy to be there, which is like we need to be having RTO, recovery time objective as 0, which means like I'll speak in detail on this one. So it's a term where we say like we cannot have our application going down even for 0 minutes. So they said like we are ready to bear the cost, because if the application goes down for a certain interval, then they have to pay fine, which is going to be 10 times higher than what we are paying for the secondary region. Okay. So these kind of decisions would be made by the product owners. And you also need to ask these questions when you are building this cloud platform. When you are responsible for creating this cloud infrastructure, then you need to ask your uh, product owners all these sorts of questions. So being an architect, or let's forget about the role, architect or developer or an engineer, you should be firstly having this idea like who is going to hit? Is it an application or is it an user? How many requests can are we expecting? How many? What is the load we are expecting? Like, is it like frequently we would be seeing 100 requests, or only during a certain period we will be seeing peaks in requests? And what is the payload they're sending? All of these things you need to ask your product owner. Only then you have to design your infrastructure. And also you need to ask them what is their RPO and RTO. Will come in detail on that. And based on that also, you would be deciding whether you need to deploy your infrastructure in one single region or another region. So on all these, all these factors matter in deciding how to create your infrastructure. Sometimes you would go with traditional EC2, which is an EC2 instance, or sometimes you go with Lambda function because you feel like the number of requests coming in would be very ad hoc and probably very less. So you feel like I would go with Lambda. And so it depends. So that is what I was saying. So you need to ask all these questions to your product owners in deciding how the infrastructure should be. So we spoke about compute, we spoke about IAM roles, we spoke about CloudWatch. CloudTrail also we have seen. I've shown you a demo how the events are logged in the CloudTrail. Basically for auditing purpose, it stays for 90 days. And after that, it purges that events, because we don't want to store all of that content, right? So only 90 days is the maximum period where the events are stored. And after that, you can also move it to S3. So all of that is there for auditing purposes. Again, if you want to go back to an year old data, that is still available, but it's in S3. Okay. So CloudTrail, I've shown you on uh, who is logged in. If someone makes any changes to Lambda function, if someone deletes anything, all of that is logged in. So it's easy and no one can escape saying like, no, I haven't done it. Okay. So that's the main usage of CloudTrail. Now, the third thing after compute, after storage, the third thing is databases. So we would be using databases as well. We would be creating databases for our clients or for our developers. So what options do we have? I'm going to tell you. And um, you need to understand that you're not a core database administrator. You need not be a core database administrator. You are primarily responsible for launching instances or launching infra for the application users. So you need to understand if someone comes back saying like, I need a certain database flavor, let's say Postgres or MS SQL, you are responsible for launching them, but you need not require to have full expertise on database. Okay. So when I say but we should have good amount of knowledge on what kind of database we are launching and how do we launch it. So I'm going to give you an overview of it. Let me share my screen. Yeah. I think in your previous projects, you must have used databases, right? So we have relational databases and non-relational databases. I will not go into too much of details, but relational is basically a structured database. Okay. So SQL, so you must have written query languages, right? Structured query language where you would try to use select statement, update statements, insert statements. So all of that you would perform on a relational database. Okay. It's not that there's no query for NoSQL, but that's also there. We'll talk about it. So basically, relational databases are used to store structured data. You can see by the diagram itself, it is having a proper schema. It is having a proper tabular structure. You know what items you need to insert. Even if you forget to insert them, it would throw an error because it is expecting a certain value to it. So that is structured database, okay, when compared to an unstructured one. So structured database examples, you can see Microsoft SQL Server is there. Oracle has its own, and MySQL, it's a free community edition database engine. PostgreSQL is there. Aurora is coming from the Amazon itself, and we have MariaDB as well. Okay, so now what is non-relational? Non-relational, as I mentioned, it is not structured ones. Okay, so it's mainly the unstructured data. So let's say for OLTP, online transactions applications, which is could be e-commerce or whatever, wherever you need that OLTP, you would use relational databases. Okay, because you need, let's say, I would give you an example of an ATM. Okay, ATM, you go to the ATM and you take out money. Okay, and it's against your account number, and you are the user to it, and at what time you have taken, let's say 10 a.m. Okay, all this information gets stored into the database. Okay, and it expects few columns. Let's say there are few columns like who is the person, what is the ATM card number, what is the PIN number he entered, what is the time of insertion, and how much money he has deducted or asked for, and whether the transaction is successful or not. So all of that is a structured thing which is going into the database. So in that ATM scenario, they would be definitely using structured data. So all transaction based kind of things would go into structured data, payment card industries, all of that. Okay. Unstructured non-relational databases are mainly used for OLAP, which is analytical purposes, big data. So big data and all, they use unstructured data, which means like data would be coming from multiple sources. So let's say uh, for we had COVID previously, and there's a lot of data flowing through multiple data sources. Okay, so one country would give you like a different database structure, other country would give you a different database structure, or someone would give you a CSV, someone would give you a structured one. So it's like a combination of different data sets, and but you need to analyze all of that data to make something out of it. Let's say people are trying to create a vaccine out of it. So they would be needing some data from all the patients. So everyone is not following the same way, right? So let's say a particular hospital would follow a different database structure. Some other hospital would follow a different database. Someone will follow manual way of inserting things. So all of this data, which is getting in as a unstructured one, because there's a lot of different data models. So when we want to uh, combine them, then we use something called as NoSQL databases. And NoSQL databases, we have multiple examples to it, which is all of this, which you are seeing on the screen. MongoDB, Apache HBase, Cassandra, DynamoDB. DynamoDB is Amazon's one. So I think definitely you would have heard about it. these are non-relational NoSQL databases where it's a key value kind of thing where you can add multiple. Uh, it's not like you have structured columns, structured rows. It's like in one row, I've attached like 3 fields. In the second row, I will attach 10 fields. Let's say for me, I'm just giving an example. As I mentioned, it's a kind of a key value kind of thing. For Sampath, I mentioned the languages known are like three languages or 5. For someone else, I would mention 10. And along with languages known, I would add one more thing like vehicles he drive, some 2 or 3, along with some more information like family information, XX. So for one person, I have just mentioned the language is known. For the other person, other item, I'm mentioning multiple other details as well. So you can clearly see that if you want to insert the same thing into relational, it won't accept. It will say like, no, I can't because I need this set of data and I need only those items. If you send more, I won't take it. If you send less, I won't take it. So that is how relational databases work. But whereas with NoSQL databases, you can send whatever you want and it gets stored. And there are some query languages on how to query them effectively. So that's again a second part, and that you would not be involved in it. There are analysts who would be writing some queries to get them out of it. If you have heard about Hadoop, Hive, Pig, those are those query languages. I mean, Hadoop is not the is the base, but Pig and Hive, they are the query languages. Spark is a query language. So these are query languages for non-relational databases or big data databases. So you have different other types of databases. I think so many database types are there. Time series, document DB, multiple other types of databases are there, but you need not know each and everything. You should be knowing SQL, which is relational, and these, and you need not know each and everything. You just need to know relational database and within relational, these are the different types what we have, and even some more are there, but I've just mentioned only few here. Relational means it's having a standard schema and all, whereas for non-relational, it doesn't have any schema. It is used for storing huge amounts of unstructured data. Okay, and these are the examples of non-relational. And we have in-memory databases. So in-memory databases, as the name suggests, it says like it the results are stored in the cache so that it can serve the request from the cache itself. So what happens if it's storing from the cache? It is faster. So the request will not go into the database every time. So it saves costs because you need not go to the database every time and it also saves time. I mean, the latency is very less because it's not going till the target database, rather it's taking it from the cache. So an example for this would be your any e-commerce cart, be it Amazon, be it I don't know, I don't want to name any few, but Amazon, Flipkart, you select few items, right? You store them in the cart, but you don't actually buy them. Let's say it's still in the cart. When you want to buy them, you will go into the cart and you will buy them, but you have a wish list, let's say, yeah, favorites and wish list. So all of that is stored in the memory. So it is very quick that from the memory, it will see like, okay, in the wish list, these are the items are there, and it don't even go into the database. So this time it goes from the memory and gets those data. So that is one of the use case where in-memory databases are used. Okay. And I'll give you one other use case. So we are working uh, on AI models. Okay. it is, we are hearing about ChatGPT and all, right? So there is one use case where we need to reach out to ChatGPT and get some data. Okay. So reaching out to ChatGPT through, there is an API called as OpenAI's API. So ChatGPT is a product coming from OpenAI, and they have provided us APIs. So basically, if I need to make a request to that OpenAI or ChatGPT in short, and to get the response out of it, it takes money because I'm using their service, and that service is not always free. You can use some ChatGPT online, but that is only let's consider it as a trail version, or it's a old version of ChatGPT. It's not using the latest models. But if you want to use the latest models, then in that scenario, you have to use some pay for it. You have to subscribe for it. Okay. So basically, you're trying to make a request to that OpenAI and you got a response. But if the same query is made for is used by multiple other teams or multiple other members, they also are asking for the same query. Okay. You already have made this request and you know the response to it. Okay. But what if your 10 other members in the same team is looking for the same answer and they make a request to OpenAI? So I'm actually duplicating the cost here because I have a response already coming from OpenAI, which I can share it with multiple other team members as well. But what's happening here is instead I'm making a request to OpenAI directly for the other 9 members as well. So this is not predictive because it's not cost effective. So in that case, this in-memory databases also come into picture where my 9 other folks next to me, when they are making a request to OpenAI, they would first look into that in-memory database to see, is there anything with respect to the similar query? Okay, the query which I make. If it is present, then the response would come from the cache instead of the OpenAI. Okay, so that is really a cost-effective solution because I'm not reaching out to OpenAI. Rather, I am reaching out to my cache where the response is already stored because someone else has already asked for it and the response is there, and I can leverage that one. So that's the advantage of using in-memory databases. So we have Memcache, Redis. These are the popular in-memory databases, and Amazon's one is Elastic Cache, which is a flavor of nothing but MemoryDB and Redis. Now we are going to speak about Amazon RDS, Relational Database Service. So we have spoken about in general, we have spoken about databases, relational databases, like what are databases, what is SQL database, and what is NoSQL databases. But now let's talk about what is RDS. RDS is basically nothing but it's a service coming from Amazon, okay, for launching database services or launching database engines. Okay. So before going there, or how would I launch an database instance? Okay. In general, what I need to do, I need to create a server. I need to download the package of MySQL or MS SQL and install that on my EC2 instance. Okay. So that is the traditional way of launching um, any database. If it is Oracle, then I need to procure Oracle package, install that software on my server, and the endpoint will have like Oracle database would be installed on it. So those are the traditional methods. Okay. But the problem, what are the problems of doing that, following the traditional ways? Is basically you are not a database expert, first thing, or you would need a database expert for installing those Oracle and managing them. So maintenance and management is very key. Like you need to do some patching, you need to do some maintenance activities like purging of the data. Yeah, there's a lot of space constraints would be there. So you need to purge them. You need to take backups of them. So all of that is a way how we manage database services, and that is the reason you would be seeing like there are teams called as database administrators specifically in any organization. And you would be hearing like, I'm an Oracle administrator, I'm an MySQL server administrator, or probably a generic database administrator. Okay, this was probably 10 years back. I've been hearing like DBAs are the core guys, they're highly paid ones. But now it's not the case, because all of that has been offloaded. So what organizations have realized is, why would, I mean, I'm not criticizing anyone, but I'm just saying like how the transformation happened. Okay. Even this would come for every developer or even a cloud administrator as well in the future. Like everyone will think like, why would I hire you? We are there only for that particular duration. In this particular duration, I'm saying cloud is the best and everything. But in after few years, we we are responsible for learning something else and being available in the market. So we cannot stick to cloud forever. It is applicable for every role, I would say. So just keep in mind. So previously, 10 years back, let's say database administrators are highly paid because there's a lot of skill required to it. They do manage maintenance, management, patching, whatnot. Uh, so organizations have realized that what is the need for it. Okay. What if we, in fact, I wouldn't say organizations, I would say cloud providers have thought that, what if we give them as a package that application teams need not worry about database. They just need to say what database I need, and we are going to launch them a database. And in the backend, whatever maintenance activities are there, patching, we would take care, replication, we would take care, backup, we would take care, because taking backups is very much important. Making replications are very much important, because whenever there's huge amount of load, huge amount of read requests coming in, if everything is going into the same node, then it would not scale. It would throttle. Your request would be throttle. It says like, hey boss, I'm not able to serve you requests because I'm over occupied kind of thing. So you would create a replica out of it. So replication and all previously database administrators would do, and that would be done asynchronously, which means like it would slowly replicate. But with this cloud service providers, they have ensured that it is synchronously replicated from this node to another replica node within 0 seconds or less than 1 second. I would not put 0 seconds, but less than 1 second, the data is replicated from this node to another node. Okay. So what happens is, a request coming in from the application, instead of going everything into one single node, it is now balanced to both the nodes. So this helps, right? And you are achieving it in less than 1 second. And other part is, let's say in a database recovery scenario, you need to copy this database. I will call it as a snapshot or a backup, let's say, and you need to copy it into a different location. Okay. In AWS, definitely we would copy it into a different region to have high availability. So all of this, which was done manually, is now not at all being done manually. Amazon RDS provides all of this features on its own, which means like replication is taken care by them. Disaster recovery, which is like copying backups and moving it into other region, is taken care by them. Scaling of space, which means like I have a database engine. I have mentioned it as 500 GB, let's say. I have a PostgreSQL database. I've mentioned the size as 500, storage size as 500. Today, I will not be having an issue. Let's say after a month, I've seen suddenly like it's already 490 GB occupied. And what happens? Your database performance would impact, your incoming requests would impact when the storage is not there, and your database would crash eventually. But with Amazon RDS, the storage also scales automatically with zero downtime. Okay. So, and you are paid only for the amount of space you are utilizing. So you can see the advantage over here. You are paying only for the size, which is only using 50 GB or 100 GB. You are paying only for that 100 GB space, not to the rest, which is available or empty. So that's one of the core advantages. Okay. And you can scale it without having any downtime, zero downtime, basically. And you can replicate it within less than 1 second. And all the maintenance, like taking backups, is actually done on the fly. You just need to say like what is a maintenance window or no maintenance window. Maintenance window means basically at what duration I want my backup to be taken. You want it when there is no load, right? So that during that time, even though when there is load as well, it doesn't matter. Probably they would say like users might experience high latencies or response times would be higher, but that was in the previous case. But these guys have advanced a lot. So even at any point, when you take a backup, it's not going to impact the existing live application. So taking backups, it even stores the transactional logs as well. So it's not just insert statements, all of that is made as a backup. Even the transactional logs who are also copied, and they are available till 35 days. Okay, so you can see, and transaction logs are really important if you want to do some restorations and DBA, database administrators, generally use them. And we won't get into that particular stage where we look for transactional logs, but that feature is available. So in short, Amazon RDS, Relational Database Service, is a service where we can launch these types of database engines and forget about how to maintain them. Okay. So in our today's demo, I will show you how we can launch multiple types of database engines. And there also we will see IAM role. There also we will see security groups. Okay. There also we will see subnets, like into which IP range it should, the instance should launch. So all of that in today's demo, we will see. Again, a traditional way for databases, you will not be seeing all these metrics. But with Amazon RDS, you have metrics related to the compute, you have metrics related to memory, we have metrics related to storage. Okay. And it also supports encryption, which means like by default, I mean, basically, organizations would say that my database should be encrypted at rest and in transit. In transit, we use something called as secure socket layer, SSL. That is the reason you would use whenever you are accessing any website, you use HTTPS instead of HTTP. HTTP is old way where hackers can easily make some violations, and they can get our data. They can read our data. But with HTTPS, it's a secure socket layer. So hackers would not be able to easily get into or breach our data. So that's there. But what about encryption at rest? Rest means on the storage, on the database, on the EC2 instance. So REST. Transit is what I told you before, which is HTTP and HTTPS, or TLS, TCP and TLS, which is at network layer. At rest means when it is stored on the volume, how is it encrypted? So basically, in a traditional way, database administrators are responsible for encrypting the data so that even someone without the encryption keys, they should not be able to view the database content. So it's a manual way of dealing things. So it's a legacy. Now, this RDS thing, it provides encryption as well, encryption features at rest. So you can just say like, what is the key which needs to be used to encrypt this data? And you can also generate a customer generated key as well. There is a different service which is called as Amazon KMS, Key Management Service. And you can create multiple keys, and you can assign one key to this RDS. When you're creating an RDS, relational database, uh, then you can say like, this is the key which needs to be used, and you will say this key, who will have access? How is that again? It's tied to IAM. In the IAM, for me, I'll say like IAM KMS decrypt. I mean, I'm just giving you an example, which means like I'm saying I have permissions to use this key to decrypt any content. Okay. Would that suffice? No. I also need access to this database. So in my IAM policy, I need to have KMS decrypt. I need to have RDS permissions as well to log into that actual RDS service. Okay. So IAM is also integrated. It's a core component. CloudWatch is also core component because you are now seeing it. Okay. And what is the advantage apart from these? You can stop your database for at least 7 days. And this was long back. I have to check the latest documentation. But I can stop my database for 7 days, and again, I can start it. For this, when I stop, I'm not paying for it. Whereas, can we do it for a traditional database server? We cannot do it, right? It's always charged. I mean, so the advantage of this cloud is you can stop the EC2 instances earlier, and database instances you were not able to stop earlier. But later they have given this feature of stopping the database instances as well. So you are charged only for that running time, but not for the stopping time. So that's one of the advantages. And you can also have event notifications. Let's say a database is created and it creates an event. You can send out an email to someone else. A database is modified. You can send out an email to someone else. A database backup is taken through an automation or manual way. Someone has taken backup. An email is sent to someone, like someone else means nothing but operations team. So, or administrators. So it supports Amazon RDS supports event notifications as well. So best use cases for Amazon RDS when you do not need full-fledged RDBMS functionality, like you are responsible. See, even you buy a car, sometimes people would choose for base variant, sometimes mid variant, uh, based on their requirements, right? So mostly everyone will not use all sets of features. Okay. Similarly, with databases as well, there are a lot of features because databases have been developed from how many years? Literally, I do not know. But there are tons of features, even database administrators won't use it day in, day out, right? So when your core responsibility is like, hey, create a database where my majority is like my applications are doing simple inserts, updates, simple deletes, and I need to have a backup. I need to have a replica. That's the major thing, right? So for all those capabilities, when you do not need full RDBMS functionality, then RDS suits you well. And if, as I mentioned, IT departments do not have database expertise, so hiring a database expert was costly affair earlier, and now, uh, just a second. Um, Okay, I'm just cutting a call. Okay. So hiring database experts are literally it's not cost effective in this era because they charge more, and so we want to offload that. So that is the reason you wanted to go with Amazon RDS, because the maintenance, everything is taken care by Amazon itself. Okay. Procuring of infra, backend, how much instance type it should have, everything is taken care by Amazon. Databases that require easy to use failover options, which means like if you want to take a backup, move to some other region. Okay. If let's say you're having a hardware failure, in traditional case scenario, what you would do, you would look for one more server. You would have a database backup managed by DB administrators. You would copy that database server, snapshot, and you would restore that snapshot into this into this new server. First of all, you need to know like whether you have any suitable server available. So all of that comes into picture. But with RDS, what happens if there is any failure in the database server in particular availability zone or particular data center, it within fraction of seconds, it launches this one in the different availability zone. Okay. It's all automated. So users are not going to see any glitch. Users would not be impacted. So it's an easy failover option where the database endpoint would be now pointing instead of this particular database in one particular data center. Now this endpoint would point to another database node in a different availability zone, which is nothing but a different data center. So the endpoint, the final endpoint or the IP is not changing, only the underlying target is changing. So that's the advantage of having RDS. When does RDS doesn't help? Okay. When there are scenarios where you want application teams to, it's a core database intensive application, and your majority is like only database. There are some legacy applications where core database functionalities are required. Then in that case, RDS would not help because RDS would come with some set of limitations. Okay. And RDS also does not support all types of database engines available in the market. RDS supports what is majority, like MS SQL, Oracle, PostgreSQL, MariaDB. So whatever is majority used, RDS would support. But in the market, every day a new relational database is created by someone, some new developer or a company, and RDS cannot scale at that pace, right? If they need to support a particular database engine, they need to do all of their background. So in that case, if you need a particular relational database type which is not available, then RDS won't help. And you already have some database experts, like let's say you have 50 database experts in your organization and you want to manage it by yourself, then RDS is not required. In that case, also you could use cloud. If let's say you have, once again, I just wanted to check. Can you hear me? I just saw something like network unstable. So can you put it on the chat, please? Yeah, thank you. So in that case as well, when you have a lot of database expertise, but you have to launch a database instance, but when RDS doesn't help, you still can launch a database on an EC2 instance. See, EC2 instance is the basic thing you need to think like EC2 instance is nothing but a server. Okay. So you need not say like, okay, Amazon RDS is not there because it's not suitable for Informix, let's say, or SAP. So I cannot just go back to this customer saying like, hey, I cannot stand up your database on cloud. You have to procure an on-premise server. I cannot say that because AWS also helps you in deploying your database on an EC2 instance. And deploying on EC2 instance also has multiple ways. One, you have AMIs, and these AMIs are coming from that particular organizations, and they are put it onto the marketplace, Amazon marketplace. And when you are launching an EC2 instance, Previously, we selected Windows, we selected Linux, but this time you can select any database engine. So what happens when I launch that EC2 instance, my selected database engine is also launched. But what is the disadvantage of it? I need to manage this EC2 instance, like patching I need to do. I need to manage the storage of this EC2 instance. And also, I need to worry about the licensing cost as well. Let's say Microsoft's SQL Server is there, Oracle is there. These are licensed. So you need to pay for the EC2 instance, and also you need to pay for the licenses for this one. You can also have, there are multiple ways. Again, they say like BYOK, no, BYOL, bring your own license or bring your own key. So if you have your own license key, then you can procure it that way. Or if you need a license key, then you can subscribe like that as well. You need to pay for the license. So all I'm saying is you either can launch these EC2, I mean, database engines using an AMI, or the traditional approach is launch an EC2 instance, get the package downloaded from that particular, from internet or from the particular organization, and you can follow the prerequisites. Prerequisites would say like, yeah, I need 8 GB of RAM, I need 400 GB of storage space, and I need so and so virtual CPU cores. All of that they will say, and after that they would say like you need to extract this package, you need to install this, you need to create a user. There's a lot of, previously I've done this creation manually few years back, and it generally takes me couple of hours to launch a database server. But that's all gone. With an AMI, it is so quick, but with an RDS, it is even better. You need to decide based on your use case. So I was talking, right? You need to pay for that EC2 and also for the license. And MySQL is a free, so you need not pay for MySQL, but for Oracle, these types, you need to pay for the license as well. Okay. Now let's go into the console. I would stop my screen for a while. Let me share back again. So I logged into my AWS console, and this time we are going to something called as RDS. Or before RDS, I wanted to show you how we can launch a database engine from an EC2 as well. That's a regular one, right? So let's see how we can do that. Launch instance. So you can see here, every time we maximum select Amazon Linux, or in our organizations, as I mentioned, we would select our security team, whatever they have released it, we would select them. So if I go into, come on, my AMIs shared with me, which is like, we have a central account, and from central account, they would share the AMIs to us. Yeah, so this is my AMIs and shared with me. So you can see this is shared with me. Owner is a different account. Owner is a different account. It's not from coming from my account directly. So that different account has shared me an AMI to be used because it clearly says it's a hardened one. CIS hardened is nothing but our security team has hardened it. Okay. So, so these are shared with me. And in the quick start AMIs, you can see these are provided by Amazon. Okay, I need to close some applications to improve performance. Okay, let me close some. Okay. So in this one, uh, let me see if I have any database. Windows SQL Server, SQL. Let me search with SQL. Yeah. So you can see there is one RHEL 8 with SQL Server 2022 standard edition AMI. Okay. When I search with SQL. Now let's see what is there in the AMIs. If I search with SQL, this is Marketplace, AWS and Marketplace. You can see 663 results are there. Okay. And there are tons of AMIs and different flavors. And this is coming from Amazon Web Services. And you can see there is something from Insight Technology, it seems. So it says like hourly billing. So different companies can, if they have different versions of the database engine or they have newer features addition to the existing ones, then they can provide or publish their AMIs in the marketplace. And if I like it, then I would search for it and I would uh, select it. And here also they are saying like starting from, they also give like how much they're going to charge. They're saying like $50 per hour or 50,000 per year. So that is how they're going to mention how their billing would be. So basically what I mentioned, what I wanted to show you is, so you can launch any, let me say Maria DB. Okay. So Maria as well, you can see there are a lot of other things coming up. So you can basically select what is applicable and from which particular company you want to select. Okay. So when you launch that AMI, you're agreeing to the fact that you would be paying that amount, license amount. So it would be billed to your Amazon uh, account. So I would say not to touch marketplace because it's cost. So it's basically you should be testing only the quick start AMIs, only free tier eligible. Do not select anything from marketplace because you would shell out money. Okay. And community AMIs, as you know, those are actually free. Okay. Here also, let's see if anything like MySQL is there. Yeah. So you can see Ubuntu MySQL is there. And this, they're not mentioning anything on cost because it's free. Okay. But the underlying EC2 instance is not free, but only thing the free is it's a community AMI where people can just publish their work, right? So those things they can, even I can create an AMI and I can say like this is going to have something like a costing application which you can use it for free, or if I wanted to keep it as paid, then I can put it over here. So it's up to us. Okay. Moving back to our moving back to our core thing, which is our relational databases, which is RDS. So with the AMI approach, we are responsible for the space management, we are responsible for the patch management, we are responsible for creating any replicas, whatnot, everything. And only case when we would go for AMIs is basically when the database engine is not present, available in the RDS, or you need a particular feature which RDS doesn't support. Only then you would go for a dedicated way of creating them. Okay. So you can see already 4 databases are created in our account, or sorry, 6, no, 4, because one is reader and writer. I mentioned, right, replicas and all. So basically, uh, this is one of the database, and you can see no one is using it. You can see 0 sessions are there. What is the CPU percentage? 4% only. So based on this, you will actually need to take a decision whether I need to reduce my instance type. So T3 dot X large is, I think, 16 CPUs, I guess. So I feel like, okay, the CPU is not at all growing big. So I can reduce it to a medium instance. Okay. So that is one thing. And sometimes it also gives you a recommendation saying like, this is not at all being used, so shut down. So AWS also gives you recommendations. And what is the engine? It says like PostgreSQL here. Okay. We will now go into creating one as well. You can see whenever a notification comes like this, it is a new feature. So till date, I was actually looking for this blue-green deployment for RDS, and it was not available. And they have just mentioned it here saying like you may want to consider using blue-green deployments to minimize your downtime. So this is a new feature. Okay. And also they're saying introducing Aurora IO optimized. Aurora is again an Amazon database engine. It says like that offers predictable pricing for all applications and improved price performance with up to 40% cost savings. So every time they would launch new instance types and give us some cost benefits, because they do not want us to move away from one service provider to another service provider. Because let's say when it comes to cloud, you can go with hybrid as well. Hybrid approach in the sense you can have uh, EC2 instances in AWS, and you feel like, hey, databases, I feel Aurora, sorry, not Aurora. Azure is a best service provider for databases. So in that case, instead of provisioning databases here, you would go to Azure because their databases are much stronger, or probably they're pioneers in databases, or probably they're cost effective. So in that case, you can go with a service launched in other service provider as well, like be it Azure or Oracle. Okay. So that's hybrid way of doing things. Even hybrid doesn't mean everything should be in the cloud. You can even have database service on premise as well. Okay. If you want to leverage your existing infra, then instead of procuring one more on the cloud, you feel like, hey, my existing database infrastructure would suffice, which is on premise. So I would leverage the same thing. I would use my cloud resources for latest technologies for something else. And for databases, I would still use my on-prem. So that is also hybrid. When we are combining, when we have different combinations here, we call it as hybrid. And you can say create database. Within this one, you have standard create and easy create. It will give you like recommendations and all. I mean, best practice configurations are already included. And standard create is like you need to create all those configurations. And engine options, you can see previously IBM DB2 was not there, and now they have included IBM DB2. But these are the database engines which we can choose. Okay. And out of which Aurora is the best one compared, because I mean, basically, it's Aurora is a database engine coming from Amazon, and it supports MySQL and PostgreSQL. Okay. Both are community editions, and basically they have fine-tuned this database engine because it can scale automatically. It is much faster when compared to rest of the relational database engines. Um, it supports multiple replicas as well, like 8, 10, even more than that. I'm sorry, but it can easily support beyond 10 read replicas, which means like I have a database and I have tons of requests coming in, and every request would then split to multiple replicas, and it would serve the request. So all the write requests would go to only the main master node, but read requests would go to all the replicas. So that's going to serve your request very faster. And Aurora supports multiple read replicas, whereas compared with the rest. Let me see how many Aurora supports. Aurora read replicas. Yeah, you can see Aurora DB can contain up to 15 Aurora replicas. So it can support 15 Aurora replicas. So that's whereas with other database engines, it wouldn't support that much. Okay. So let's say I'm going with PostgreSQL, and next you have different Postgres versions as well. They generally release Postgres versions, right? So you can select which one you want, and they only release once they tested it on their platform, and after rigorous testing only they release these versions. Okay, and enable RDS extended support. This is again a new feature. They're saying like it's an paid offering. I don't want to do that. This is again a new feature as mentioned. And when use production, it would select a different instance type. When I say like dev or test, it would select a different instance type. That's again ease of access, I would say. So let me select dev test. Okay, just an identifier, and you can create a username, password. Okay, and this username, it says like managed in AWS Secrets Manager, which means like the the user would be created with Postgres, and the password would be stored in a vault. So vault or Secrets Manager, both are one and the same. It's like a secure place where my secret is stored over. Otherwise, self-managed, which means like I need to pass the secret here. Okay, or auto generate. So once after it's created, I just need to see the view credentials to see what auto generated one, because auto generate would give you a strong password. But if I want to provide one, then I can provide one. But again, these are all old ways. Latest is credential managed in database manager, which means like it would create the password, and it would use this encryption key. We spoke about KMS, right? Encryption at rest and all. So this is the encryption key which is being used to encrypt this one and store it onto the secrets manager. So once after this is created, you need to go into that secrets manager to look at the generated password. And what next? This is again new one feature. Again, if you want IO optimized or standard, this is cost effective and this one is cost intensive, but this will easily provide you faster read writes. Also, you based on your requirement, you need to select which one we need to choose. And here also you can have like serverless, where the patching and everything, even with server as well. But we need to look into that info. It will give you like which one is best suitable for us. Serverless provides on-demand auto-scaling configurations for Amazon Aurora. It automatically starts up, shuts down, and scales capacity based on your application needs. So when my requests are not coming, it will shut down the database engine. And this is also released like 3-4 years back. Previously, serverless was not there. They've released it. So every year a new feature would be released. Okay. So they're saying like burstable means whenever there's a lot of requests coming in, then they would provide super if performance instances so that your responses are quicker. Okay, so memory optimized, what does memory optimized instances? Accelerate performance for workloads that process large data sets. So according to your use, you would be selecting. So here we have selected memory, so it gave one instance type. Let me select something else. It modified burstable class, it modified, it's a medium one. And let's say if I select other one, it changed automatically. So let's say if it is memory intensive, here also I can select either a higher instance type or a lower instance type. Okay. What does it say? You can see here, previously databases were supporting 244 GB of RAM, but now I'm surprised to see it even supports 768. This was not there earlier. Oh my God. So it's there even 1024. Oh my. This is this is too good. This I would say not to select these kind of instance types because they would empty our pockets. If it's an organization, only if it is asked to do so, only then do it. Otherwise, stick to medium or micros. Okay, this memory intense starts from R5 large, which is of 16 GB. But let's say burstable, it starts from medium, okay, which is of 4 GB RAM. So let's say 4 GB. Multi-AZ, as I told you, multi-AZ deployment. If you click on here, it will give you, it creates a replica in a different availability zone so that when there is a failure in one, it's easily able to restore it. Failover would be very quicker. So some organizations would need an replicas. So we would select replicas. Okay. And we would say like which VPC I need to choose, where my database should be present. Okay. And public access. If I need a public IP, then I would select this one, but usually it's no because databases are sensitive. So you would not provide public access. And this is nothing but security groups. So you need to select who will have access to my database server. Okay. And also, this is IAM authentication. IAM authentication is nothing but instead of username password, if you want to have IAM, then you can use IAM database authentication. So in my, let's say an EC2 is where application is deployed and application needs to connect to database. You generally provide like when you're creating the DB client, you would say like DB client dot host. Host is this IP or the RDS endpoint name, and DB client dot username, you would provide Postgres. DB client dot password, you would provide it. If you do not want to provide that username and password thing, then IAM database authentication is the way to go. You can see here, password authentication is always enabled. IAM authentication manage your database user credentials through IAM users and roles. Okay, so this is again a new way of new thing which has been added, IAM authentication. Okay, and retention period, how many days I need to keep. Okay, the backups, I guess. Okay, this is for performance insights. Performance insights, how many days I need to retain them. So that's 7 days is free, and I can disable it. Enhanced monitoring is again comes at a price. So you need enhanced monitoring or not, you have to look for it. and select the logs types to publish to Amazon CloudWatch. So if I want my database logs to be submitted to CloudWatch, then you can do that as well. Okay. And you can also see the estimated cost here. It says like DB instance is 59, storage is this much, and approximately you would be paying $61 per month for this one. If I change the instance type, let me go here, memory, and 024. Okay. I've selected 1024. What does it say? $13,000, 550 USD per month. Earlier it was $65, and this instance type is $13,000. So you have to see how uh, it is exponential, not even exponential, it's crazily going high if we wrongly select any EC2 instance. So please be careful, and I'm not going to create database, but this is how you are going to create a database, and this is how it's going to look here. So we have launched something which is very micro, which is free tier, I guess, and X large is like 8 GB RAM, and yeah, I think we need to make some actions on this. So this is how you would launch relational databases. And yeah, I would recommend you to try launching a very small instance type of database, and you can use, if you are using Postgres, then you would use a client called as pgadmin to connect to that endpoint and insert records. If you use MS SQL, then you would use that Microsoft SQL Server client to connect to it. Similarly for the rest of the database engines. So that's how you are going to test your database. So this concludes our today's session. I hope you understood the importance of databases in cloud and how we need to launch them. What are the available launch options of launching them through AMIs, through manual way, or through Amazon RDS? RDS is the core for today's topic, and uh, so most of them whoever is using Amazon would prefer using Amazon RDS, relational database service coming from Amazon. So Alekia, I'm done from my end today.
Yes, Sampath. Maybe there will be
Hey,
any
thanks,
questions that
Shweta.
you have.
Thank you.
Any queries ready?
Thank you, Priya.
And Sampath, give me like 2 minutes. Savneet wants to speak with you.
Sure.
Yeah. Savneet?
I would request everyone to give a feedback to Alekia and Avneet on the sessions, because this would actually help me for my career as well. And probably I need to take some feedback, and I need to adjust my learnings as well if I need to do better. So please provide your feedback uh, to the learning team, key learning team.
You can make a Google form also, Sampath. Hi, this is Avneet.
Hey, Avneet, how are you?
Very well. How are you?
I'm good. I'm good.
So I was saying that if you want, we can prepare, you can
Yes.
prepare a Google form and so because we have a
Yeah.
program feedback which will not cover the SME feedback. So
Okay.
you can just make a simple, Google
Sure.
form and we will circulate the same with our candidates.
Sure.
So
Sure.
ladies, we still have one more SME session left with Sampath, which will be happening on 9th of January. And
Yeah.
so for this, I mean, like for December, we are, closing it here. And yes, that does not
But
mean
I
that
think we have covered major topics. I would say compute, storage, and databases have been covered. I would recommend everyone to just go over our previous recordings. Previous recordings are, I would say, the most important. You need not even go to any PPTs or so. Just go through the recordings. That would help. And the last session is all about uh, how to attend for interviews, how to look for course, and certifications. I would give some tips on certifications, how the certification structure is going to be, all of that. So last session is just an
A doubt
wrap-up
clearing
session.
session.
Yeah, clearing
Yeah.
session. So I would say all these 6 sessions, whatever we have done is the core. So please go through them again and again repetitively, which will help you definitely. So on the PPTs, I just got a no from legal. So unfortunately, I'll try to provide regular links or YouTube videos, but I cannot provide these PPTs. But you can definitely look into the recording, which is there. So
Yeah, recordings have been shared with them,
yeah,
Sampath. So only today's session, what has happened, the recording, it will take a day's time
yeah,
to get converted. So allow
yeah,
us that time and we'll share this
yeah,
recording as well with you. So,
sure.
ladies, please, we have provided everything from our side. Sampath has done the best job. He could to teach you all. So I just request you, please don't consider this as holidays. You have the holiday homework along with you.
Yeah,
Okay.
yeah.
So do invest the time in studying and come back with your doubts for 9th, right?
Yep.
You have
And also
enough
I'm
and more
seeing
time.
there's a lot of job opportunities being opened up. And yeah, I would say you need to build your profile. Whatever sessions you are doing, I'm saying you have to repetitively go over that recordings and try it yourself. I'm telling you, somewhere you will find that opportunity, definitely, because there's a lot of cloud resources or requirements coming in the market. So yeah, please do.
Okay, ladies, and on this note, let's, take one picture. I will request everyone to come on the, camera. Let's take one picture. Yeah, I'll just paint the view.
But it doesn't mean you have to become enemies. You need to understand why are they supporting somebody else and why.
Okay, is that all we have? Come on, ladies. Rest of you have left the session already. Is it? No worries. On the take of 3, 2, 1, 5, please. Okay.
Yep. Thank you. You always have my LinkedIn, so you can ping me over there.
Thank you.
And I will also post anything if I have, like any job opportunities, I will let you guys know. Thank you so much for
Thank you,
this
Sampath.
opportunity.
Thank you,
Thank you.
Sampath.
Thank you.
Thank you very
Thank
much.
you.
And ladies, again reiterating, please keep studying. Khushbu, I know you are very, very attentive on all the sessions. PT, you have also been, been a rock
Thank you.
for AI/ML also and for cloud also. So keep
Yeah.
going, ladies. Okay.
Thank you.
Sampath, can you
Bye-bye.
wait
Thank
for
you,
2 minutes,
Avneet.
please?
Thank you,
Sure,
Sampath.
sure.